Hey math friends, welcome to the second lesson in our second unit. This one's called solving polynomial. I'll try that again, Junior. This one's called solving polynomial equations. You've been doing this before, so this actually won't be too bad. You did this in grade 11. Make sure you got your graphing calculator with you. We need it. It's going to be super handy. Okay, solving polynomial equations. So you've done this before. Back in grade 11, we had you solve these things when they were quadratics. So that's what we're going to do again today, and then we'll see what we do when it's a degree 3 polynomial. So a couple of things we just want to go over here quickly. There's a difference between a function where it's f at x is equal to, and an equation where it's equal to a number. Okay, a small difference there. So in our table here, which I'll get you to pause and read if you would like, okay, there's a few things that are worth noting. Again, the difference between an equation and a function, okay? And when it's equal to 0, when it's not equal to 0, it's equal to another number, okay? I'll get you to go back and read these things. Mostly here, solutions are the values of the variable which make the equation true. So really it's what makes an equation is said to be true or equal if the left-hand side is equal to the right-hand side. Okay, so when we're solving, that's what I really want you to think about, is we're trying to make the left-hand side equal to the right-hand side. Okay? Otherwise, nothing that I really want to is huge importance there that I'm going to go over. Okay, what we're going to do now is we're going to go through a few different ways for us to solve equations. Now, looking at my list here that I've got typed up for you, I've got the first one is factoring in algebraic method, quadratic formula, and then graphing is C. D is something called regression. I'm going to make a video just on regressions that you can look at to follow this one. Make sure you look at that before the next lesson. However, even though I've got C written down here, I'm going to change that. It's really Z, graphing, also known as cheating. And if you're not cheating, you're not trying hard enough. I'll show you what I mean. First question says, algebraically solve the following. Okay, yeah, sure, I could algebraically solve that. Or someone in my life bought me a lovely graphing calculator. I'm going to go ahead and graph this thing. So pick up your calculator and graph this. So x squared minus 2x minus 3. So we go and we graph that. And you're going to go and find that this is going to look like this. And you're going to have an x-intercept over here at 1 and an x-intercept over here at 3. Sorry, negative 1 is what I meant to say. Well, how does that help me solve? Friends, that's your solution right there. It says it's equal to 0. So that's where this graph is equal to 0, right there. Easy peasy. So there's my answer. So if this was multiple choice or numeric response, hey, guess what? I'm done. I know my answer. What I'm going to do now is algebraically solve it. Well, I'm going to try to factor this thing. So guess what? This is x minus 3, x plus 1 equals 0. Therefore, x is equal to 3, x is equal to negative 1. Hey, look at that. It's the exact same as what you told me it was by graphing. Now, a little hint that I have for you here. I get this question that says algebraically, which means you have to show me some work. And you know you've got to factor it, but you're just, for whatever reason, you're hooking a hockey puck to the head like me, and you can't graph it, or you just can't get the answers, algebraically, I should say. But you went and graphed it. So say you found the answers graphically. Were this. Well, all I'm going to think about then is those are my factors. Remember we talked about that last lesson? Those are my factors then. So no matter what the equation is, you can work backwards. Did you see that? I just worked backwards there. Guess what? You could probably get away with not knowing how to factor in high school and just use your graphing calculator. It makes the mathematician in me cry quite a bit. Don't tell anyone I told you that, but it sure works. Okay, next one. Algebraically solve the equation by factoring. First thing I need you to notice is one side's not equal to 0. So I'm going to first subtract 5 from both sides. Now I can factor this thing. Two numbers that multiply to 8 and add to -2. Sounds like that. And therefore, x is equal to 4 and -2. Again, if I'm getting this question on a test, which I'm going to, hint, hint, nudge, nudge, wink, wink, graph it first, get the answer. So if I was graphing this thing, here's what I'm going to do. I'm just going to clear this little section here. So if I was graphing this, there's two ways to do it. I could graph this right here, but let's say for a second I graph this as it looks. So y1 would look like this, right? But in y2, I'm actually going to graph this at 5. There's y equals 5. So guess what? Your solutions are where the two lines intersect, where this thing is equal to 5. So your answers are still 4 and -2. That's the other way to do this. That's handy because then you don't have to rearrange the equation. Okay? Personally, I wouldn't do it that way. I'm just telling you that that works. Personally, I would always, just to keep things simple, I always do this first. I make one side equal to 0. Okay? Next one. Do you see this one here is degree 3? It's got 3 factors. Okay. To solve this one, look, it's already factored. It's already factored for you. There's my answers. It's already factored. I'm done. I will never ask you in 30-2 to factor something like this and solve. Never, ever, ever will I ask you to solve that algebraically. This in 30-2 will always be done graphically. Degree 3 or higher, we don't know how to solve algebraically until we take 30-1. Okay, so please don't. There's usually someone on the first quiz who tries to, and they spend the entire class, what have you been doing all class? I'm trying to solve this thing. Well, you don't know how, but good for you. Bonus marks for you. Okay, number 4, algebraically solve. Okay, so the first thing I do is I try to factor this thing. It's two numbers that multiply to -4 and add to 1. Nope, I don't know either. Guess what? There's no integers that do that. So that means we got to use that quadratic formula we were practicing. Remember, it's on my formula sheet. It's actually, I believe, the very first thing on my formula sheet. There it is. So this is considered an algebraic approach. Okay, which gives some math teachers, I'm sure, heart attack, but not me. This guy's over it. I'm happy for you. That's algebraic. And now all we need to do is simplify this down. Again, please don't just ram this thing all the way into my calculator. Remember my rant from before? I really suggest that you simplify it down first. And now that you have this, okay, really that is your solution. But if I asked you to round this, you would put in the 2 values. I've also got a fraction button on my calculator, which makes this a heck of a lot more easier to do. So the first one is approximately 1.56. And the second one's going to be negative. Right there. Okay, if you didn't get those 2 values, that means you're putting something in your calculator wrong. Go back, try again. Keeping in mind, one more time, that I could just graph that bad boy right there. And guess what? If I graphed it, those are going to be my solutions. Easy peasy. Okay, the next one, number 5. I don't know if I want to go all the way through number 5. Here's all I really want to say is when I'm trying to graph or when I'm trying to solve something, what I need to do first, if I'm doing it algebraically, is I need you to make one side equal to 0 if I'm doing it algebraically. Okay, but now I look at this thing and I say, okay, two numbers that multiply to -1 and add to +1. Can you think of two numbers that add to -1 and add to +1? Well, if you can, you're a better person than I am at math. I can't. So again, we would have to use the quadratic equation here, quadratic formula. But I'm going to go back to the question. I don't know why my "the" is highlighted there, but why, can we get rid of it? Why would I do the quadratic equation when it didn't tell me to? It said solve. It didn't tell me what to do. So if it didn't tell me what to do, I can do this any way I want. It just says solve, baby. Solve, baby. Well, I'm just going to graph it then. I'm just going to graph it. Y1 is this. Y2 is that. Then graph, right? Remember, that would be your point of intersection. And so you're going to get x is approximately 0.62, truncating, and the other one is going to be at negative something here, negative 1.62. So the moral of the story here that I want you thinking about is if it says solve, I'm not telling you how to do it. I'm just saying do it. Do whatever you want except for cheat off your neighbor. Just solve. Of course, I'm a mathematician. In my own mind, I'm always going to want you to do things algebraically, but if you don't have to, maybe you don't want to. Okay, number 6, use the quadratic equation, quadratic formula to solve this cubic. Nope. You can't. It's the quadratic formula, not the cubic formula. There is a cubic formula. You're happy I don't teach that to you in high school. So no, you can't. The only way I expect you to solve these things, is by graphing. Okay, I'm not going to do that right now, but you could certainly graph it yourself. Okay. Last question. Oops. Last question. Give this one a read. I'm going to hit pause. You're going to give it a read. I want you to think about what you're going to do here for a second. Okay? Go ahead. Hit pause. Okay, you've had a chance to read this question. This one always cracks me up. I don't know why the drawing makes me laugh so much, but it does. So you're drinking your fruity juice drink like you're in elementary school. And it says this company is going to increase the volume of the box. And currently, here are the dimensions. Now they give us the formula to find the volume. And it says the company doesn't want the box to exceed 1,000 centimeters cubed. Determine, which means show me some work, the largest amount by which each dimension of the box can be increased. Okay, so what I'm going to do here is it says that's my volume. And we're going to increase each dimension as we go here. Now, my pen has taken this convenient moment to stop working, so I'm writing with my finger, so apologies if it looks a little sloppy. So my new volume here is my current dimensions, but I'm going to add x to each amount. Okay, just like that. But what it says is I know my new volume. So my new volume, sorry, I'm kind of drawing on the fruity box picture there, is this. 5 plus x, 4 plus x. Sorry, my finger is not as nice as the pen, is it? Okay, so how am I going to solve that thing? Well, that's a cubic. So I'm not going to get you to solve the cubic algebraically. We've talked about that. What are we going to do then? Graph it, baby. Okay, let's go to our graphing calculators. Okay, you got your graphing calculator. So what we're going to do is we're going to graph this thing. So I'm going to clear out anything I got in there. So in Y1, I'm going to graph 5 plus x, 4 plus x. 12 plus x. And in y2, what I'm going to do is I'm going to graph 1,000. Now, if I go and hit graph on my calculator, I don't see a heck of a lot. I see that over there. So this is a skill I need you to get really, really good at. I'm going to go to my window settings. Doesn't matter if I'm on a Casio. Well, I'm going to change these to match the actual situations. X, what is X? X is how much they're increasing the box size by. Well, what's the smallest I can increase something by? 0. I don't. X max. X max and Y max sometimes will be guesses. Okay, what are they going to increase it to? I have no idea. Right now, the largest dimension is 12. I doubt they double it, but just in case, I'm going to say 12. That's always a bit of a guess. Scale, bigger the better. Look, I'm not even going to make sense. 100, just make it big. Okay, Y is your volume. What's the smallest amount of volume you can ever have? 0. What's the biggest volume they want? 1,000. So I'm going to go a little above. I'm going to go to 1100. And I'm going to make my scale really large. Again, the bigger the better. Now when I go and hit graph, what do I see? I see where the two things intersect. Second, calc, intersect. First curve, second curve, guess. And there it is. Look at that at the bottom of the screen there. You can see x is going to be approximately 3.5. Y is that volume of 1,000. Okay, so go back to our books here. Let's answer the question. So, what is our answer? To the nearest tenth of a centimeter. Okay, well, we graphed this thing, and to the nearest tenth of a centimeter, we found that x was approximately 3.5 centimeters. Now, it says state any restrictions on the variable. Okay, state any restrictions on the variable. Okay, well, what we're going to do here is we know that x has to be greater than what? 0. You can't have a negative length being added. Like, as soon as I say that out loud, you know it doesn't make sense. So I'm going to get you to always think about what your restrictions are. All right? Okay, these are the types of questions that polynomials are leading into. It's the applications. So I do need you to know stuff about the graphs, and I definitely need you to know how to solve them algebraically, but when we're a cubic, we are always solving cubics graphically, right? We're always solving cubics graphically. Okay, for your practice here, the first few, pretty quick, not a heck of a lot to it. Okay, the ones that are of the most importance are when we start getting into these ones here. Number 7 and 8 and 9 and 10 and 11, diploma questions. Number 12, kind of a diploma question. Okay, these are the ones that I need you focusing your time on. Okay, hope that worked for you. I will see you next time.